दिए।
सर तुम्हाला होस्ट केलंय.
Okay, I think you can carry
Yes.
on because
हो
others
सर.
have not joined. They will join.
ओके
Okay.
ओके शुअर सर. 7ला आहे मी.
Okay, sure. Thank you.
ओके.
Hello. Hello.
Sir, good evening.
Good evening. Good evening. Oh, you are very particular. I was expecting you to be there. I remember the SIB days.
Sir.
Yeah.
I think I got adapted to that timing.
Yeah. Let others join. I think we will start. We'll have to wait because it is 7:50, not even 7:15, 5:15. So wait for another 4-5 minutes.
Sure, sir.
Yeah. So, so your studies are going on?
I think tomorrow and day after it will be kind of full-fledged, sir.
Yeah. There is no lecture, no?
But like, however, I did not get much time to.
Yeah, I know that is always the case,
Yeah.
And I think you people are used to, appearing for the exams on the basis of whatever you have learned in the class. Yeah.
Kind of
And
habitual to it now.
and you do very well. I know that.
Thank you.
So, but this time you must clear the examination. Uh, and next 8 days, university you still have about 1 week. So you have to concentrate on the studies now.
Yes, sir.
Yeah, that is required because I think the level like examination is not very easy. So you'll have to maximum time you have to devote now
Yes,
in
sir.
the remaining. You are still in Hyderabad.
No, sir, Bangalore.
You are in Bangalore. Yeah, okay. So your assignments are going on.
Yes, sir.
Acha. So what sort of assignments do you do?
Sir, we do EC, environmental clearances.
Okay,
We do
all right.
ECBC,
Ah,
Energy Conservation Building Code. I'm a TPA for AP and Telangana government.
okay.
We do all the green building certifications, sir.
Oh, I see. Good.
Yeah. So we cover from IGBC to LEED, Griha, Edge, Well, Living Building Challenge. So we are like we have stepped into every possible project that has a variety. Uh,
Acha, so
yeah.
for all new projects.
Kind of, sir. Existing buildings also are there, like across India, pan India projects we are doing.
I see.
Yeah.
Okay. Mm. Okay, good. Uh, how is the business climate?
Uh, for ECBC, it's very good in AP and Telangana, but there are a lot of states which are yet to mandate this policy across country.
Yeah, I know. Yeah.
Yeah, so with that, it's really great, sir. I mean, at least we are able to figure out what kind of buildings are consuming what kind of energy. Now we have like a basic understanding. If you give me a shed or assembly building, probably I can tell on what energy savings, like
Okay.
thinking way, like practically, I don't have to do a simulation. Like,
Okay.
okay, this is the location. Now this might be the savings on a thumb rule kind of a thing. So since 2019, we have done around 625 projects, sir, for ECBC.
16 projects.
625, 625.
Oh, very large. Okay,
Yeah.
good.
So with that,
You know,
yes, sir.
very nice.
Uh,
You see, our Professor Gaurang Lele, he is architect plus also energy manager.
oh,
He's also
wonderful.
my student.
Okay.
If required, you can always be in touch with him.
Definitely, sir. Definitely.
His consultancy is Shashwat Green Building Consultant.
Okay.
So they are in green building certification.
I think I've heard of Shashwat Green Building, Maharashtra,
Acha.
Pune.
Yeah.
Yeah, I've heard of
He
it, sir.
he is also, he is also a BE empaneled and also uh, he is with IGBC. Yeah,
Oh, okay.
works with IGBC
Mm-hmm.
also. So maybe that you can uh, be in touch with him when required.
Definitely.
By the way, you have Anuja is also IGBC, no?
Yeah. Anuja is from the, I think, Green Homes team, sir.
Okay.
Yeah.
You have met her? No.
No, sir.
Physically?
No.
Okay. Okay.
I did not
Uh,
get because they get internally shuffled most of the time. I think probably
Okay.
every 1.5 year or something like that. So they
One
missed.
Mr. Atif Sheikh, one of the seniors, third batch. He
Mm.
was with IGBC for 8 years.
Oh,
Hyderabad.
okay, sir. Even Anandaditya Apte.
Anant Krishnan.
Anantaditya Apte, sir. He was at least, I think he was from 2010 batch. He was also
Uh,
part of IGBC.
what is the name you said?
Anantaditya Apte.
Anand Aditya. Emma. I think he's
Um,
early. Yes.
he was
He's
also
also
part of.
he's in Hyderabad, no?
He was part of IGBC, sir. I'm not
Then I
sure.
think one Jacob was also there. Ashwin
Yeah,
Jacob.
Abraham
Yeah.
Jacob. Yeah. And I think he
Yeah.
moved
Yeah.
to WWF
I,
actually.
yeah. I still remember some names. Yeah.
I
Because
think
usually,
you remember the students who are more not listening to class and but active in class kind of situation.
right. Yeah. One of my students, he works in Bangalore. He is a energy auditor. Shashidhar.
Shashidhar, sir. Okay.
Shashidhar, he is from School of Energy Studies. He is from 2004,
Oh,
2006 batch. Yeah.
okay.
But he has got a consultancy and works in Bangalore. In case you need you can also talk to him. He's
Definitely.
also, like you, a very close student.
Okay.
He's Asmita madam, Asmita madam, they are classmates.
Oh, okay.
Uh,
Ma'am is working with SIIB now, na, sir? I guess so.
no, ma'am is, she's teaching SIB, but she is with BBQI, Bureau Veritas,
Okay, sir.
on carbon. Atik also is in carbon, carbon crediting, CCTS and all.
Correct, sir. Correct.
Of course, lot of training, other trainings also she does.
Oh, they're giving
So,
training or they also do carbon footprint analysis
yeah,
and others?
yes, right, right.
Okay, sir. I think
Yeah.
I can get in
So,
touch with her.
hello, Akshay.
Hello, sir. Good evening.
Yeah, yeah, good afternoon. Okay, so I think it is time to start because it is 5:20. I think Sagar, we say whether when he will join, we don't know. Whether anybody else going to join, I don't know. Okay, so shall I start? Are you comfortable? If we start,
Yes.
Mr. Prita, shall we?
Yes, sir. I'm fine with it.
Okay, you are able to hear me properly?
Loud and clear, sir.
It's clear, no?
Yes, sir.
Okay. Again, just to repeat, I am also, I have connected on the PC also, just as a backup, but I will be using my laptop for the presentation. So already the recording has started. So our conversation for last 5 minutes is recorded, Ms. Saprita. So don't worry about it. Anyway, I'll
Okay.
share.
I think I can go back and check the names.
Yes. Okay, I'll share PPT. Okay, so you can see the PPT. Is it visible to you?
Yes, yes, sir.
Okay. So let me start. This is the 14th chapter in book 4. And we are going to talk about performance assessment of buildings and commercial establishment. In book 3, there was a chapter 10, which was energy conservation in buildings and ECBC. So we have gone through that chapter. So many of the concepts which terms, terminology, definitions, and concepts which we discussed in chapter 10 are will be used also in this particular chapter. Okay. So maybe to some extent you are familiar with some of the terms that we are going to use, but in case you have any issues, if you want to know any clarification, we can always go on discussing. Okay. So what we are going to discuss as a part of today's lecture, which is lecture 44, the topic is performance assignment of buildings and commercial establishment. The objectives of this particular chapter is first to study and understand the energy performance index and annual energy uh, you know en- energy performance index EPI, which we have of course studied in book 3 chapter 10. The second thing that we are going to study and also uh, study more is assessment of cooling load, and third is the assessment of HVAC system and assessment of lighting system. Basically, the chapter 10 was regarding for the design purposes, which was more meant for the provisions to be made in the design, architectural design, regarding the and limiting the energy consumption. So reducing the energy performance, consumption per square meter EPI. Whereas this particular chapter, we are going to deal with the use of energy in the buildings, how to use the energy in the buildings more efficiently to keep the energy consumption down. Also, we are going to study the use of equipment which govern actually the energy consumption after the building is ready, and the utilities like uh, you know uh, electricity, of course, is the first one. Air conditioning is the second one, major one, and water supply system and ventilation system and so on, which are required for all types of building. For certain. So since we are only going to concentrate on commercial building, we are not going to talk about any other building. So basically, electricity consumption, for the lighting and also for the equipment that it will be used in the buildings, and the utility systems which are installed in the buildings. So we are going to talk about that. So let's go to let us start first here with. So the major consumption in the commercial building is obviously the first comes to our mind is HVAC. Although we are saying HVAC, most of the places in India it is the air conditioning. And then we have got lighting systems. That is another major node of lighting, and commercial buildings. It's a very large lighting load. Then we also talk about the office system, office equipment, which is used by the in various types of commercial building, and of course that will include not only offices, but will also include, hospital. It will also include hotels and so on. So all these buildings, the lighting load and other equipment load also is fairly high. Okay, so our objective is to reduce the energy consumption and therefore the energy cost by proper utilization of the equipment and its energy consumption through proper operation and maintenance of various utility systems. So we'll go ahead with that. Now, once a building starts operating and we start using various equipment, HVAC system and lighting system and other systems, for the existing buildings, what needs to be assessed every year, is the performance. So let us go to the performance assessment. The purpose of assessment is to find out whether all the systems are working properly, efficiently, whether we can reduce whether there is a scope for reduction in energy consumption, and whether we can some step over there. Okay, and in order to assess the performance of the existing building, what we need to do is to analyze its envelope, whether for the purpose of energy reduction. Also, what are the load profiles, especially air conditioning system load profiles and the electrical load profile. What are the system efficiencies for HVAC system, and also we have to find out the total cooling loads. We have to find out the total lighting loads. Also calculate certain ratios which we compare with the standard ratios to find out whether we are operating within limits, whether electrical load is okay, is within limits, whether air conditioning loads, what are the air conditioning loads, and what is the what the performance of the system. Okay, so the first thing that we have to understand is that for building as a whole, the parameter to be assessed, worked out and assessed is the energy efficiency, energy performance index, EPI. Okay, so EPI is, as you know it, it is defined as the total energy consumption divided by the built up area of the building. Now, the total energy consumption includes both the electricity bought from the electricity board or the grid, and also electricity which, if it is generated, through diesel generating cell. Okay, so the total consumption will be sum of these two, and total built up area. Of course, these figures are known for the building, for most of the buildings. Otherwise, you have to measure and calculate it. It becomes a exercise. So architects usually will give you a built up area. So this calculation, it gives you energy performance index, EPI, and then EPI can be compared with the standard values. It can be compared every year with its own sale to know whether how building energy consumption is taking place year after year, whether there are improvements, whether it is reducing, or not. And also it can be compared with other buildings, of similar buildings, of course, uh, of similar size, similar consumption, to find out how it is comparatively, whether our building is efficient or not. Then the second parameter, which is also used for comparison of energy efficiency of a building, is the average annual hourly energy performance index. Okay. So this short form is AAHEPI. So obviously the this is defined as energy performance index divided by the number of operating hours in an year. Okay, so it is EPI in expressed in kilowatt hours, so, per year, per m square per year, and operating hours per annum. So these two figures are need to work out now, and there is an example which is solved over here to explain how to calculate this. Of course, this is easy, but then it is better that we understand better once if there is a example given. So there is example in 14.1 which says that commercial building has got an built up area of 17,814 17814 meter square is the built up area, and the consumption of annual consumption of the buildings, from the electrical supply grid, is 37 lakhs 35,640, 3735,640, and from its own generation by using DG is 29 lakhs 64,758, 296,475. Obviously, the energy performance index, if you calculate, would be total consumption. So 37 lakh 35,640 plus 29 lakh 64,758. You can see this expression, or on the screen, and divided by area 7,814. The answer you get is C76. So energy performance index is 376 kilowatt hours per m square. Okay, so uh, this is the value, and the average annual hourly energy performance index will be this EPI 376 divided by the number of operating hours. And it is mentioned in the example that facility operates for 12 hours a day and 250 days in any year. So 376 divided by 12 multiplied by 250, and it is to be multiplied by 1000. Okay, so don't forget that. And the answer that you get is 125. So average annual hourly EPI is 125. It was not 125. So this calculation is always required to assess the performance of a building or overall performance of a building. And then, of course, we will go to HV system and the lighting system later on. But overall figure you get by these two performance parameter. Okay. Now let's go to the next step. That is the this average annual consumption as well as the EPI. They are the building envelope plays a significant role, in the annual energy consumption, and the basis of design of the building it needs to be known. The building should have been designed by the architect to ensure that the EPI value is kept low. In fact, these days architects make use of several software to ensure that EPI values, through alternate designs, they are reduced, and you come to optimum value of API at the design stage. And when the building is constructed, then of course we have to ensure that this EPI values are complied with. So that's why the first part of the assessment is this one. Now, just to explain again, to go further deeper into finding out how the rooms, get heated, you know. So this picture is shown over there. It's a very good picture. So you can see a room over there, in which a person is sitting and working, and then there is a heat, which is getting access to the room through various places. You can see that on the left hand side there is a solar sun shown. So the solar radiation comes through the windows. So that's what you can see. Also, some air infiltrates into the room through the gaps between the window and the wall. So hot air out from outside goes inside. So it heats the inside atmosphere. And if the room is to be air conditioned, therefore we have to first calculate what are the heating, what are the loads, what are the sources by which internal atmosphere gets heated, or so to say, what are the heating loads, what cause the heating. So one is the solar radiation coming through the walls, second is infiltration air, third is through the glass, some certain amount of heat conducts inside, so it is through conduction. Also to the external wall, some amount of it goes in, because although brick wall is the insulation, but it's not 100% insulation. So some amount of it can go inside. Okay, so these are the external walls. Then again, the roof. So the roof also, similar, the heat will find the ingress into the room, and then also from the floor. Suppose the floor is heated, or below the it's there is another room, then it can get heated up. So also the room may have some partition also from the other rooms, to the partition walls it can come in. So these are various places from where the heat will enter into the room. So this and in addition to that, you have got lighting system. We can see the lights over there. So the light, of course, not only uses light, but also it produces some heat, and that is a heat load on the air conditioning system. Also the equipment that is used, the computers, that computer also, there is a heat generated. And all of us know that laptop will have a fan because there is some internal heat developed. So heat is generated, even the laptops and computers and other devices, office, maybe the printer, maybe there some other devices. And also the people sitting when working in the atmosphere, they also constitute a load on the system. So this explains the sources of heat gain into the building envelope, in the room envelope. Okay, so all these loads we had to assess, we had to calculate the heat loads and assess, take this value for further assessment. Okay, so this is basically the heat loads. So now let us, having understood what are the heat loads, which the figures have to be used while assessing the air conditioning system. So it becomes essential to calculate the heating loads for an envelope or for a building. So let us now go to the assessment of HVAC system. So that is the first thing that we need to understand. So you all know that in order to assess the HVAC system, firstly we must know what is the total HVAC plant capacities, what is the layout of HVAC system, because in the given buildings, what are the design parameters which were used for working out the HVAC capacities, and uh, what constituted, what are the basis of load that were considered for deciding the HVAC plant capacity system. So main objective of the assessment of HVAC system is to find out whether the operating kilowatt, of the refrigeration, whether the existing load on the HVAC system in kilowatt or tons of refrigeration, uh, you know, and what is the actual kilowatt, you know, con, you know, uh, load actually we can measure, and the ratio of actual load that we can measure and see over the refrigeration load in terms of tons. Refrigeration load means the cooling load. So this ratio, is, it is to be compared with the design value to find out whether the air conditioning system it is provided is functioning properly or not. Okay. So this is the purpose of the exercise, to calculate the heating loads on the system, and also measure the kilowatt, present. So since we all know that air conditioning system basically has got four major components. One is, of course, the chiller or compressor, which is a major device in the air conditioning system. Then you have got the chilled water system, you have got cool water system, and we have got a cooling tower. And what we are talking of is not for the air conditioner, but we are talking of a air conditioning system. So when air conditioning system is installed for cooling a building, there will be air conditioning plant, and we have to find out what is the kilowatt of compressor, what is the kilowatt rating of chill water pump, what is the cooling water pumps kilowatt, and the cooling tower, what is the load. And we have to assess each of these components for their performance. Okay. And we have seen in this book itself in chapter 4 how to assess the performance of chillers, how to assess the performance of pump, how to assess performance of fan, and how to assess performance of motor, and also assessment of AHU and assessment of cooling tower. Okay, so this again will not, it's not repeated here uh, because this is already covered in chapter 4. Okay, so in order to assess the performance of the HV system, we need to do in-depth assessment of all these component: chiller, pump, fans, motors, AHUs, and cooling tower. So methodology for that is already described in chapter 4, except in the cooling tower, where the methodology is described in chapter 3.7. Okay, so this can be referred to. Plus, in addition, the ASHRAE handbook also can come very handy because all the procedures for performance assessment are based on what is mentioned in the specified in the ASHRAE book. Okay, so for here, first let us see what are the terminologies used. I will not go, go further. Space, of course, space, room, zone. You all know about it, but there are certain terms which are often used, in the calculation of heat load. One of them is the cooling load temperature difference, cooling load temperature difference, CLTD. That is equal to the temperature difference, between the external cooling load and internal cooling load, either wall or a room. So that defines the cooling load temperature difference between either for a roof or a wall. The temperature difference is outside and inside. Okay. Then there is a sensible heat gain. That means heat coming from outside by conduction, convection, or radiation from various sources. It is sensible heat gain, which goes into increasing the temperature of atmosphere within the building. Okay, ambient within the building. Then there are certain loads, where the heat is not does not increase the temperature within the atmosphere, but it is because the moisture that is present in the room, it gets heated up by outside air. So it also constitutes certain load, and its moisture can maybe because of the people working over there, they produce some moisture, through their inhaling. Then maybe infiltration of air from outside. So some of these sources are, this given over here. Then there is a radiant heat, which is the heat, that is radiated within the space from, from outside. Space heat gain is rate at which the heat enters from various sources, uh, you know, in a given time interval. Space cooling load is what is the total load inside, which constitute the load on the air conditioning system, which generate heat and constitute load in the system. There are two factors which are very important and you always used, in building design also, civil architectural building design. They are thermal transmittance of, or what is the heat transfer coefficient, uh, usually expressed in terms of U factor. It's a very popular term for the architect's U factor. And there is so U factor is the rate of heat flow through the unit area of a building. That means the wall or the roof, so unit heat flow that is taking place in per square meter of this air, and this U factor is therefore expressed in watts. So heat is not expressed in heat units, but heat is expressed in terms of watts per m square. So watts per m square is the uh, thermal transmissions or the heat transfer coefficient. Then we have got the thermal resistance, which is reciprocal of the heat transfer coefficient, or the U factor, 1 over U factor, you can say. And heat transfer is the resistance of uh, uh, you know the material, to conduction of heat. So to say, it is the thermal resistivity of various components of a building. Okay, so opposite of thermal conductivity, which is the thermal transmitter. So these are the two terms are extensively used in heating load calculation. Now, what are the types of loads? Although I just mentioned to you earlier, with the picture that was shown over there. But let us describe in more details what are the types of loads. One is, of course, the one classification of loads is the sensible load, so sensible heat gain, and secondly latent load or the latent heat gain, which is a moisture gain or wet water vapor in the room, which which receives the heat. Okay, so under the sensible loads, we include the heat gain coming through the envelope, exterior walls, roof, gazings, and any exposed room, including the floors, okay, and the skylights. So heat that we get from these sources. Then the partition walls that we explained, also the ventilation air that is supplied inside the envelope. So that constitute the sensible load. Also because that temperature is reduced, and air filtration that takes place also constitutes the sensible load. People in the building, of course, because just as the atmosphere gets cooled to people, our body temperature, is a little higher. If you want to maintain temperature of 25 degrees, 26 degrees in the air conditioning fan, the body temperature, the, uh, the heat divided by percent also will have to be, uh, that heat also is to be taken into account. And then, of course, the equipment, appliances which are working in that particular envelope also uh, constitute the sensible heat, and also the lights, that is the lamp, that is the wattage of the lamp lights is also the sensible load. The latent heat consists of, again, it is the people when they breathe, they inhale air, and they also exhale air. So through exhale air, that our breath, when we breathe outside, then inside, you see the breath is always hot. It is going to add to the heating load. Cooking equipment, housekeeping, floor washing, etc. Some operations also do contribute to that. Plus, in addition, of course, if you have got, let's say, coffee maker or some, you're boiling water, the water that goes into the atmosphere also constitutes a latent load, and ventilation air, which has got a, or the moisture, infiltration air, which will like to have some amount of moisture, so that constitutes latent load. So this is the classification of load. The cooling load also is classified in another way. That is, one is the external load and one is the internal load. I don't think it is necessary to explain that. So what are the loads, sensible loads inside the envelope is the is the internal loads, and whatever the envelope gets heat from outside, you know, uh, they are the external load. So I think we need not further discuss on that. Okay. And then again, there are some terms which are used when which are to be calculated also. They are basically, one is the CLTD, that is the cooling load temperature difference, CLTD. That second parameter to be worked out is the SCL, that is the solar cooling load factor, and third is the CLF, or cooling load factor. So these three have to worked out, on the basis of methodology given in the ASHRAE handbook. So those who are conversant with the heat load calculation will know about it. So I really don't know whether energy engineers will find it difficult to do this calculation, but they can always refer to the Ashtray handbook, or they can refer to the book, this chapter, or they can refer to the architects and air conditioning people for this particular calculation. But for the examination purposes, you will have to solve some examples, and so therefore these terms must be known to you. Since it's an open book examination, you need not remember, in your memory, but you can always read it. So CLTD is a theoretical temperature difference. We defined it earlier, between external and inside internal, uh, of the envelope. Okay. So, and CLTD will vary based on the outside temperature variation, daily. You know that temperature varies from morning to evening, from in different places. It will vary, and so depends on the condition of atmosphere, solar. If it is cloudy, the temperature will be low, and so on. Okay. So also cooling factor CLF, cooling load factor also depends on the radiant energy that enters from outside. That is also very varying, and both these factors can be calculated on the base, using the formulae within the guidelines method given in the Ashtray handbook. Third is the STL factor, which is used for adjustment of temperature heat gain, is from the glasses, solar heat gain, through glasses. Okay. So there is an example which is given here. So there is calculation given here. So it wants to assess the cooling load in an envelope using CLTD, HCl, and CLF method, which is Ashray method. So we'll just go through the calculation so we can understand this method to an extent. So it says that that determine the cooling load given the following parameters. One is the area of the wall, which is given as 15.7 meters square. Second is the desired inside conditions are required at 240, 25.6 degrees. Relative humidity to be maintained is 50 degrees centigrade, and the details of the wall, there are values are given here, you know especially walls being, it will have aluminum windows. So R value for aluminum siding and concrete block and insulation and so on, these values are given here. Okay. In addition, it's mentioned that there is a film of air outside the wall and also above the roof, which also contribute to the air conditioning load. The air is moving at rate of 12 kilometers per hour. So on the basis of which, there are calculations are done, and so these calculations will be given later on. The values given are area is given 13.7 multiplied by 18.3. Space is occupied by, from 8 o'clock to 5 o'clock in the evening by 18 people. Lighting load is at 12.1 watts per m square. That is the lighting power density. Computers and all, load is 5.4 m square. So these are the figures, values given here. We are supposed to calculate the heating load. So the U factor of the wall, how to calculate, for the entire wall. So wall consists of, also the sliding. It consists of concrete blocks, insulation, indoor air film, outdoor air film. So U factor, composite U factor, how to calculate is given here. Composite fill factor, the roof also is given here, because same parameters will be there, that will be, the insulation provided by the roof, slab, and there will be concrete and so on. So this can be calculated with the help of architect also. It can be calculated. Okay. And then external heat gain, can be from the wall, from outside, can be calculated like this. The U factor value mentioned is 0.33. Area which mentioned earlier also 50.3. Area of the windows is 14. Net wall area is 15 minus 14, that is 36.3. Outdoor temperature is 35. Inside temperature to be maintained in the air conditioning is 25.6 degrees. So the heat conducted from outside or heat gain, it worked out as 0.33, which is the U factor multiplied by the difference, but this is the area difference. That means the actual war area, 50.7 minus 14.4 is equal to 36.8 into temperature difference. Okay, so this is the heat, conduction gain in watts. Okay, it's not calculated in calories or some thermal unit. It's in watts. So this is the heat gain through wall. So similarly, heat gain through uh, other components also can be calculated. And Ashtray gives some CLTD factors; those can be used, for further calculation. So with all these things, heat gain through the wall, the final figure is, the final calculation using the CLTD, because the temperature, conditions vary over the period of time. So we need to calculate the average temperatures, uh, outside. So CLTD factor is to be used. CLTD factor is to be, for 17 hours is to be taken as 12 degrees centigrade as per the norm, standard norm. Although actual temperature difference may be small, but this is to be, for purpose of calculation of cooling load, we have to take this as a 12 degrees centigrade. So heat gain will be U factor multiplied by area of wall multiplied by temperature difference, which is CLTD, standard temperature difference, not the actual one. Is equal to 140.33 into 36.3 into 12, it is 144. This is the heat gain in terms of in expressed in watts. Okay. Similarly, heat gain through the roof can be calculated using the similar factors by using the roof area, which is mentioned here. U factor for the roof also will be varying, and CLTD, as for the room, will be, of course, will be different, because the roof outside temperature is going to be high, temperature is going to difference is going to be high. So it is 44. They can this multiplied by this 0.32 multiplied by 13% multiplied by 44, it gives the heat gain through roof. Similarly, one can calculate the heat that gain or heat conduction through the windows. So we'll have to use the respective figures. First of all, you have to calculate what is the window area and use the various ratios over there. Again, this formula remains the same. Okay. Similarly, heat gain, by radiation through the glass. Water direct radiation falls on the glass, so heat gain through the glass of the windows. There is an expression given here, which is equal to quantity or the of heat, solar radiation, heat gain, solar heat gain HSC is equal to area of the surface of the glass multiplied by shading coefficient. But of course, because there will be, for the windows there will be glass, there is shading, and SCL, that is the solar cool load factor. So this factor, of course, you will have to take also the help of architect if you want to calculate this. Okay. For the exam purposes, you can go refer to the books. Okay. So this calculations will show you, heat gains in different components, like roof, windows, glass, and so on. Okay. So these calculations are further, mentioned. So solar radiation is explained over here. Various factors are explained here. I I think you can understand. You can go through that if example is there. You are required to solve some example. Similarly, so these are the external heat gains, roof, wall, glass, uh, glass material, etc. And the internal heat gain, of course, can be calculated very easily, because knowing the number of people, the heat gain from the people can be known, because by knowing the sensible heat per person and the latent heat per person, these values can be taken from the standards, and you know uh, they can be used in using the formula mentioned here to calculate the heat gain from the people working in that area. Okay, so example is solved over here. So we can, uh, which mentions here that internal gain from people in this example in this space can be again used by using the Ashray tables, standard tables, and from the tables it is observed that people participating in moderately active office generate 75 watt of sensible heat and 55 watts of latent heat. Now, these are the standard figures which need to be considered for purpose of calculation of heat gain from the people. So, in this particular area, earlier example, it was mentioned that 18 people are working in this particular room. So, the sensible heat gain is equal to 75 watt per person and latent heat is 55 watt per person. These are the standard ASHRAE values. And CLF is to be considered as one because there's not variation, uh, much variation over there. And so then the heat load calculation is 18 people, 75 watt per person is the latent sensible heat. So this and CLF is a 1.0. So this works out to 1350 watt and the latent heat gain from the 18 people is 18% multiplied by 55, 18 multiplied by 55, which is equal to 990 watt. So the total heat gain latent plus sensible is 1350 plus 990. So this is from the people. Similarly, if you have to calculate the heat gain from the lighting, obviously the heat that emanates from the lamps. So you have to know that wattage of the lamps, and you also know how much heat is apart from the light, how much heat is developed by each lamp. So that is the sensible heat. So these values are also given over here. How much heat is radiated, by a lamp and also along with the lamp, because this book is old, so it is considering only the tube lights or CFL. So there is a ballast factor for LED which would not be there. And there is CLF cooling load factor, which is also specified for this type of construction. So if you take the values, there is example which is solved, to calculate the heat gain from lighting and the heat gain from lighting, it works out to area is uh, uh, of the building is given here. Floor area is 13.7 by 18.5. That's the floor area. You know, uh, you have got then lighting density is 21.5 watts per m square. This is specified. So area is 13.7 by 18.5, so 50.7. So the total lighting energy is this multiplied by area multiplied by watt density, LPD lighting density. So this is 250 by 25.5 is equal to 5,400 watt. And fluorescent ballast factor is to be taken as 1.2 for the fluorescent lamp, and CLF is to be taken 1. So the heat gain from lighting or is 5,400 is the lighting load in terms of watts, multiplied by ballast factor 1.2 multiplied by CL1 is equal to, so heat load is 6,480. That's how it works out. So just like lighting, one can also calculate the heat generated by the equipment. So for that you will have to know the wattage of that particular equipment. So it is mentioned that computers and office equipment, the lighting load is 5.4 watts per m square. So you multiply by the area, which is the same over here, to 50.7. So that gives you the sensible heat gain from the equipment. So this is how you calculate for the equipment. Then also there are calculations given for to be made for heat gain through infiltration. So there are formulae given here. They are the standard formulae which need to be used. So figures of area, volume of the space, airflow are given here. So this can be calculated. So so you can calculate heat gain from the infiltrated air that it leaks into the atmosphere because of because of the gaps in the walls and also in the roof. Okay, or maybe also windows also. So infiltration airflow calculations are mentioned over here. So with all calculations done, this is a summary of the heat space cooling loads or the heat loads on that particular space. So this summary table tells you, this is one is what is the space load component. That means the first is the conduction through exterior walls. What is the sensibility? The figure worked out earlier was 144. This is the same example carried forward. Conduction through roof was 3560. This is the figure also, which appears earlier. Conduction through windows, value was 359, which is also worked out earlier. Radiation through windows is 3447. That is also worked out earlier. For the people, we just worked out is 1350. And the latent heat also we have mentioned for the people is 990. Lights we worked out 6480. These figures is mentioned over here. These are the figures mentioned here. These are the figures mentioned here. 1354 equipment, lighting is 6480. So these figures are given as a summary. So this becomes a summary table. Okay, for the heat load calculation. And then infiltration air is also mentioned. Equipment load also mentioned here. Now there is the equipment latent heat and infiltration latent heat. These calculations also as per extra procedure. They can work out, and this is the summary. So summary of heating loads in this particular space is sensible heat load is 21,623 and latent heat is 2,599. So these figures are to be used for performance assessment in that system. And then there are some additional input heat gains. One is heat load due to ventilation. That is also to be considered. So these calculations are also mentioned here. How to calculate the heat load of the ventilation. Now, what is ventilation load? In air conditioning system, you have to supply, some periodically you have to supply some, fresh air. So that is called the ventilation load. So that amount of air has to be supplied. So there are some air changes, which are specified in the air conditioning system. So you will have to supply that much of air, at intervals. So that constitutes the ventilation system gain. Okay. And then with HV system, there are some other equipment like fans are there. They will also constitute to the heat gain. Their blowers are there, fans and blowers are there. That will constitute also the heat. It will so that can be also calculated. And this to the summary table, they will also add the ventilation loads, so which is earlier. These are the earlier figures 21,623 that you can see. This is the figure 21,623 and 2,550 latent heat load. These figures are carried forward over here in the summary table. Add ventilation load, for the fans, which is calculated here, 2047 and 2079. So this total is these are added together. So the total load, cooling coil load, how much air conditioning system load will come on the heating load will come on the system is sensible load sensible heat of 23,670, heating load and latent heat load of 5,709. Okay. Similarly, there is supply air with, uh, you know, ventilation is basically for the fans to be ventilated, the supply air to be, replaced at intervals. So supply air also the heating load is calculated in the similar manner, and that total constitutes the total is calculated, of the summary is calculated. Okay. So this is on the whole how heating loads are calculated. Okay. These calculations are not very, you can't remember all these things, but understanding is required. That there are so many constituents which will contribute to the heat gain. So I will like to uh, again repeat those for convenience. Okay, so let's start. Before we switch over to the lighting, assessment of the lighting system, let us try to recapitulate what we have studied as a part of the heat load calculations uh, for the AC system. Okay, so I will shall I repeat it again so that you'll remember before we go to the HV system. Shall I go through it again very quickly? Mr. Wade and Suprita. I know it's not very, uh, it is loading us, putting a load on us, but we have to understand this, as for the purpose of the examination. So, shall I repeat it? Hello, there is no answer from you, both of you. Hello, are you there? Suprita and Akshawade, are you there? I don't hear from you, anything from you. Hello. Are you there on the line?
Sir, am
But
I
you are not
audible?
answering. Now you are audible. I will. Well, I was not. I was wondering whether both of you are there or not. Uh, okay. Let me check whether Akshay is there. No, because he is also not responding. Just a minute. Hello. Hello, Suprita. Hello.
Sir, am I audible?
Okay, so I will repeat it once again because what we learned it's a totally new subject. So I will repeat uh, a few minutes for you. I think Akshay may be driving. Yesterday he was driving,
Sure, sir.
so maybe we will continue with this. Okay, let him respond. Hello, Mr. Akshay, are you able to hear me? Okay, so let me start from the beginning, just to recapitulate, what we have studied, so that we remember it. So we started with this. We started with the definition of uh, you know uh, the performance parameters. So one is the energy performance index, EPI, and the second parameter which is used for building, assessing the energy performance of building, is the average annual hourly EPI. So the expressions are given over here. The energy performance index is equal to is the total sum of electricity consumed in per annum divided by the area, built up area of the building. So this is expressed in kilowatt hours per n square is the EPI. Average annual hourly energy performance index is short form is AAH EPI, which is EPI divided by the number of working hours of that particular envelope building in hours per in an year. So these two indexes are calculated. We have seen the examples, how to calculate these values. So values are 376 and 125. So this is what we studied. Then we said that the major, assessment of the cooling air conditioning system, HVAC system, is is to find out whether the cooling loads, what are the cooling loads, actual cooling loads, and what are the conditions. So basically, the first exercise, the whole exercise is calculating the heat loads, that exist in practice, because your air conditioning system, is based on, there, of course, there are uh, several calculations which are required to be done. So assessment of the HV system is, basically the energy performance is to be calculated in terms of the kilowatt, of that particular system, load of that system, divided by the tons of refrigeration. This is the parameter to be worked out. So for the chiller and the pump and the fans and motor, this uh, you calculate what are the kilowatt per ton of refrigeration. So these two are these 4 5 parameters are worked out, to assess the performance of HV system. Okay, so existing kilowatt of the chiller, divided by tons of refrigeration, which is air conditioning load, that is worked out. Pump capacity is known. So uh, for the air conditioning system, tons, uh, you know, uh, kilowatt provided per ton of refrigeration. These figures are worked out. And methodology for calculation of this is mentioned in this chapter 4 for chillers, pumps, fans, and AHU, and also the cooling tower. So in chapter 3.7, so those calculations are done is in the existing figures of the HVC system. Okay, the uh, system that is installed. Okay, so that is, and then we also make the measurements of the kilowatt. So what is the chiller kilowatt? What is the pump kilowatt? What is the kilowatt of the fans? Actual measurement. Also the motors, what is the kilowatt, and what is the AHU kilowatt, and the air conditioning, tons, refrigeration loads, that is what out, refrigeration. So that for calculation of the refrigeration load, we have to do certain calculations. So this is what we will see later on. So this, of course, the methodologies given are given over here. So basically, this kilowatt of these various chiller pumps, etc., they are known. But what we need to actually assess is the heating loads. Okay. So I converted it into terms for refrigeration. So that exercise, what we are going to, what we have seen. Just to repeat, there is a term which is called the cooling load temperature difference, CLTD. There is a sensible heat gain from from various sources outside as well as internal equipment, etc. From various sources. Latent heat is, for the people who are working, it is the heat that goes on to add to the heat load, but it doesn't increase the temperature. Sensible heat is the heat that comes in, from outside, glass, windows, roof, etc., walls, but which increases the temperature inside. So that is the sensible heat. So we have to calculate all this. So these calculations are given. We have seen it, but we will repeat it again. So also the radiant heat gain, space heat gain, that we have seen. And there are two factors. What is it? Thermal transmittance factor, which we have to calculate, and the thermal resistance we have to calculate. So we have understood what is sensible heat, sensible heat loads, which result into sensible heat, imparting to the envelope. Also the latent heat, from which sources we get. So that what is the latent heat load? That also we have seen very in this over here. And then we have also seen the heat load calculation. One is from the external loads and one is from the internal loads, heat loads. So segregation of loads is done that way. And then various factors like CTL, TD, SC, ECLF, they are calculated. They are taken from the ASTRAE handbook. Okay. So then we had proceeded with the seeing what are the calculations to be done. So first of all, uh, calculation of the heat load, that is terms, in terms of of course, it is given not in terms of the thermal units, but in terms of the watt. Load is calculated. So first we saw the cooling load, calculations by using ASTRAE method. You have to see. So this is explained in this here. I will not repeat this calculation, but one can calculate, the U factor, calculate from of the wall, roof, and then we go to the calculation of heat gain, for which the formulae are given over here. The procedure is also given here. How to calculate the conduction heat through the walls, how to calculate conduction heat to the. So this calculation is given over here. We have seen this calculation, so I will not repeat. The procedure is, it is multiplication of U factor by that means the solar heat gain coefficient multiplied by the area of the wall, and how many hours, what is the temperature difference between inside and outside. That this determines what is the total heat gain in that particular area. Similarly, heat gain, through the roof is also, calculated in a similar fashion. So also heat gain through windows by using the proper factors of, U factors and proper CLTD by also, and measuring the area of that roof, wall, windows, etc. And then what is the solar radiation through the glass in the windows? That is the next stage of calculation. Also, what is the radiation gain? These calculations are given over here. Okay, so these are the external loads. The internal load heat calculation is using, basically the heat gain from the people. There is latent heat, the number of people, and the latent heat, sensible heat per person. So also the latent heat of people also is there. That is latent heat of people multiplied by latent heat per person. These are standard figures which are taken from ASHRAE. This is 75 watts per, sensible heat per person. This is 55 watts, per person. These are standard figures which are considered for the calculation. Okay. So heat gain from the people is calculated here, depending on number of people working in that area, and the CLF is taken as 1, or here there is a standard method. You can calculate the heat gain from the people. Similarly, heat gain from the lighting is basically, it depends on the total wattage of the lamps. Wattage of the lamps can be you can take the figures from the actual wattage of the lamps installed. So exact total wattage of the lamps which is installed, multiplied by, assuming that this is a fluorescent lamps, ballast factor of 1.2. CLF is taken as a you know cooling load factor, which is usually taken as 1. Okay, so this way we can calculate it knowing the lighting load. Now sometimes the lighting load may not be specified in terms of the total watt for each of the lighting fixture, but it may be given as a lighting load, density, lighting power density, in which case that lighting power density you have to multiply it by the floor area to get the total lighting load. So that is the total wattage of the load into ballast factor and CLF multiplication. That gives you the total heat that is generated and imparted to the space by lighting. Okay. So also the equipment, of course, you'll have to know what is the total kilowatt, what is the, office equipment load, printer load, and any other load, any other coffee maker, tea maker, etc. You have to add those load in terms of watts. Okay. So that gives it a total wattage. So also the air that comes in, it gets infiltrated, through the leakages, through cavities in the wall, doors, or maybe windows. So that is also is calculated. Formulae are given over here, so you can calculate that. Heat gain from the infiltration air. So again, the summary table is mentioned over here, whereas earlier one we had in the summary table we have mentioned these figures. So conduction through walls, exterior walls, conduction exterior roof, conduction through windows, radiation gain through windows, you know uh, uh, and the conduction. So these two are different. Radiation is what directly passes, solar rays pass inside. Conduction is because the temperature outside is higher than the inside, there is a conduction of heat. So these two components are different. One is the solar radiation passing through the window glass, and one is actually the conduction from outside air to the inside air because of the temperature difference. Then the centimeter lighting code from the people is calculated. Procedure calculations are given above. Lights are, also we calculated. Equipment load we calculated. Infiltration we calculated. So this is a summary of space cooling load. Okay. Add to that the load due to ventilation. That means the ventilating fans will be there, and some other, so their loads there is are to be added to this, and also the system gain, heat gains because of the equipment, that is because of the motors, because of the fan blades, because of the ducts, and so on. So that gets to is to be added. So this is called as the ventilation load. Uh, you know, so this gets added over here. You can, so the earlier summary table 2163 plus 2599. You add these loads of ventilation system, and also air changes have to be done as per the ASHRAE standard. So many air changes per hour. So supply air is to be also added at interval, and that load is is to be added to this particular summary. So this is how the heat load calculations will be done for the air conditioning system. Okay, I just repeated it because this subject is not, we are not very conversant, so I thought I will repeat it. Okay. Okay. Shall we proceed further? Ms. Suprita?
Yes, sir.
Okay. Akshay Wade is there? Hello, Mr. Wade. I don't see why you're not there. Let me see. No. Okay, let's not worry about that because he is not responding. Uh, okay. So let us go to the performance assessment of the lighting system now. Uh, just like air conditioning system, this is another very important system in the for the buildings, and it's important to calculate, to assess the performance of the lighting system, in a building. So in all buildings there are different types of lamps are installed. They have different wattages, in various areas of the particular building. So we had to calculate the total lighting load. Now, total lighting load will consist of the wattage of lamps in various areas. But usually there is a practice that they define what is called as the lighting power density. So what is lighting power density? That also, when we studied illumination, it was mentioned, it was described over there. But again, I will repeat, lighting power density is the ratio of total operating lighting load in watts, not kilowatt, in the watts. So it is to be expressed in the unit in which it is to be expressed, it is watt. So the total operating load, that is working load, installed load may be different because there may be so many lamps which are installed, but they may not be in operation. So what we need to consider is the total operating load, which is functional load of lighting in watts, divided by the built-up area. That is the lighting power density. Okay. When the lighting system is designed, of course, they take into consideration that all lamps will be operating and the total built-up area, this figure is known to calculate lighting power density, and that's how design will be done. But in actual practice, there may be, all lamps may not be working, but so you have to know what is the total lighting existing, at a particular, time, uh, point of time. Okay, so uh, now first of all, let us see how the calculation of lighting power density is done. Okay, for an existing building, it's not at the design stage, but in an existing building, if you have to assess what is the lighting power density and whether it conforms with what was the design figure, that is what we had to assess first as the assessment of the performance. So there are different areas in a building. So it mentions here floor 1, floor 2, floor 3, administrative building, amenities building. This particular building has got 3 floors plus administration part and amenities part, cafeteria. So these are the areas, uh, you know, and there are total number of lamps are mentioned here. You can see that floor 1 is 165, lamps. Floor 2 has 212 lamps. Floor 3 has 568 lamps. Administration has 83 lamps, and amenities, cafeteria has 260 lamps. So this is the total number of lamps. The wattage of each lamp in each floor, assuming that they are the same, same lamps are provided, in in floor. It is assumed. Actually, the example gives the same wattage of lamp. That means the same type of lamp is used, but it can be actual lamp wattage can be different in different areas. So that actual figure of wattage of the lamp that is installed, physically installed, is to be considered. Okay, so the floor 1 has 36 lamps. Floor wattage is wattage 165 lamps and 36 watts. Floor 2 has 212 watt lamps and 36 watts is the wattage. Floor 3 has 568 lamps and 36 watts is the wattage of each of them. Administration 83 lamps and 36 watt is the wattage of each lamp. Amenities 260 lamps and 36 watt is the lampage. Okay, the type of lamp is mentioned here for the purpose of our understanding. These are all considered as CFL. Okay, compact fluorescent lamp. So the total lighting load is a multiplication of 165 lamp multiplied by 36 lamp, 36 watts. So that is works out to, here figure is mentioned is kilowatt. So 165 multiplied by 36 is 17,800 watts. Mentioned in kilowatt is 17.8. So floor 2, the lighting total load is 22.86. That is the kilowatt. Third area is floor 3, where the lighting load is worked out to 61 kilowatt. The fourth is area is the admin system, where the lighting load works out to 5.98 kilowatt. And fifth area, amenities, the lighting load works out to 9.36. So these are the total wattages, total kilowatt load in each floor that is mentioned over here. Total area of that each floor is mentioned here. Obviously, floor 1, 2, is mentioned. Is the same is 2120, 2722, 4727. These are the areas of different floors, and that's why you see the number of lamps also. That is in proportion, because area 2120 lamps are 165. Floor 2 is 2722 square meter area, lamps are 212. So also floor 3, which has got higher number of lamps. Okay, so you multiply air this so the total wattage and total area. So it's the division of wattage by area. So floor 1, 17.8 is the kilowatt. So again, work out wattage, that is 17,800 watts, divided by the area is 2120. So this division works out to 8.4. So the lighting power density is worked out to 8.4. Okay. So floor 2, similarly, the lighting load is 22.86 kilowatt, that is 22,000, expressed in terms of watts, 22,860, divided by area 2022. The answer is 8.4 watts per m square. Okay. Similarly, also calculate for the floor 3. Here the watt lighting power density was out to 8.44. Okay. Similarly, for the administration area, the watt lighting power density was out to 2.8, and for the amenities it was out to 2.64. Okay. So uh, uh, this is just 1 minute. Let me. Uh, there is a message from Mr. Shaigram. I'll just reply to him. I just replied to him. Sorry for interruption. Telegram. He will be joining at 7. So this is calculating the lighting power density, and then these figures can be tallied, compared with what are the design figures which were taken for the lighting design, and so that is the first exercise. And then for in order to assess the efficiency of the lighting system. Okay, that means actual lux that is obtained by a particular lighting design, the number of lamps, etc., and what is the target lux density when the design was done. So the ratio of actual lux, that means actual illumination density divided by the target, that means the design illumination density. This ratio works out to, this is called as this ratio is called the efficacy of lighting. Okay. Now, as we mentioned, when we studied the lighting, you have studied lighting, we don't use the word efficiency. So lumen per watt, how many lumen we get from a lamp per watt of input is not called the efficiency, but it's called the efficacy. So that is called the efficacy of lamp. Similarly, the term used here is we don't use efficiency of the lighting system, but we call the efficacy of the lighting system. So the term that is performance parameter for the lighting system is the installed load efficacy ratio. That means what is the actual lux that we obtain, from the lighting system of course, per m square divided by the lux level that was calculated, provided at the design stage. So the target lux level, the term is the target lux level. So the ratio of these two, actual lux watts per m square and target lux per watt m square, this is called the installed load efficacy ratio. Installed load efficacy ratio, ILER is the short form. The installed load efficacy ratio is actual lux in watt lux per watt per m square divided by the target lux per watt per m square. Okay. So lux per watt per m square is the parameter to work out, after in physically and compared with the target which is given in the design figure. Then there is another parameter which is also needs to be calculated, is the room index. Now this room index uh, uh, is the ratio of that particular dimensions of the room, length of the room multiplied by width of the room divided by the length plus width of the room multiplied by height. Okay. So basically, length plus width of the multiplied by height is the volume. So it is the length multiplied by width divided by volume of the space within that room. So this is the room index. So this for different room indexes, there are different stipulations as per the lighting power density is concerned and for the measurements. Now it is specified, in the standards that uh, based on the room index, you have to make certain minimum measurements of the lux. Okay. And minimum lux measurement at certain minimum number of points. Okay. So what is specified is that lux level measurements or lux level is measured by using a lux meter. There is a meter called lux level meter, which tells you what is the illumination intensity. Illumination intensity is number of lux divided by the area. So at a particular, that meter directly gives you the lux level, illumination level. So that is measurement is to be done. If the room index, as worked out by this formula for that particular area is less than 1, you have to make minimum measurements of illumination intensity is minimum at 9 places, and take an average, of 9 readings to get the average illumination intensity in lux. Similarly, if the room index is between 1 and 2, the measurement is to be done at 16 places. Okay. Similarly, if the room index is between 2 and 3, measurements are to be done at 25 places. Similarly, the lux level is between 3 and above, measurements are to be done at 36 places. And then you have to calculate the average of these measurements at so many places in a room. So that is to ensure that, many times what happens that illumination, in a particular room may not be uniform. Okay. And so you may take a figure which is actually maybe higher or lower. So in order to avoid that particular, incorrectness, they are taking the average value. So this is how you calculate, you measure the lux measurement based on the room index. So room index figure are given there, and you work out this ILER using the actual lux value by target value for that particular area, ILER. Okay. So what is there are these target lux values are specified, by standards. Okay, so for different types of areas, they are mentioned in the standard books. Say book, and this particular book also mentions that. So the target lux per square, per watt per m square, that gives you the total, that indication of the illuminance, and actual lux is the actual illuminance maintained, and target lux is what are designed, on for that particular area. Okay, so again here, for there are different lux levels which are specified, for commercial lighting. So for commercial lighting, basically in the offices, retail stores, malls, etc., you know, where there is a good color rendering, that means good, we can see the lamp. So for industrial and offices, these figures are given separately. For industrial lighting, that is in the manufacturing shops, precision, warehousing, workshops, etc., where good color rendering, that means the differentiation in the color, where you can recognize one color from the other, that is called a color rendering. So where we need good color, differentiation between the colors, so that this value of target lux taken at the design stage is higher. For commercial lighting also it is mentioned, figures are mentioned. But for industrial lighting, where there is color rendering is not so important, that means color differentiation is not so very important. The values you know uh, so but color discrimination is required, so values are different. So you can see that for different room indices, room index which is figures, they are mentioned for the commercial lighting, industrial lighting, where one industrial lighting, two. So you can see that, for the normal lighting, industrial lighting, a large scale, these values are set lower, whereas for some standard installation it is higher. So these figures are provided, at the target lux level, and actual measurements are done physically at that particular place. So if you have to uh, compare, these are the figures to be taken from this table. After knowing what is the room index for that particular place, you can see what is the standard provided, that should have been provided, and what is the actual lux level that you have measured. So this ratio of the two will give you the ILER. Okay. So there is a specimen ILER calculation is given over here. So we'll go through that very quickly. So the procedure for calculation of ILAR means installed load efficacy ratio. So that means the ratio of actual lux per watt per m square by target per lux per watt per m square. This is mentioned. So measurement, the area is given as 45 m square for a particular place. The room index that is mentioned is that it is 1.93 for that particular room, and that particular room has got lighting load. The total lighting load is 990 watt. This is figure given for calculation. So the watts per m square, that is the figure which is mentioned here. This is watts per m square, for that particular area. So watts per m square is the lighting density. So that works out to 990. That's the watt total voltage divided with the area. So watts per m square density is 990 by 45 is equal to 22. So this figure works out to 22. So these are the stepwise calculation. The next step is you calculate the average illuminance, at that particular place, average illuminance that is measured. This year, this measurement at 18 points. Why 18 points? Because here the room index is mentioned as 1.93. So you refer to this table for 1.9293, that is a 2 is the nearest level, and it is a commercial lighting. So this target level should be 46. That is what is specified. Is target level is 46, is 46, whereas actual illumination is measured at this 18 points. As per this particular you know uh, as per this table 1.93. So average illumination, it is worked out at 16 places. So this worked out to 700. Because it is uh, so at 700 illumination, it's what actual measurement. What is specified, watts per m square is 22. Illumination is 700. You divide 700 by this area 22, so it gives the in actual lux level per watt. It goes as 700 by 22 is 31.8. As per the standard, this figure for this particular type of building, it should be 46. So this ratio of ILAR is 31.8 by 46. So this is how, so the efficacy ratio for this particular area worked out to 0.31 by this, that will 0.47. So 0.71 is, this is here. So some review is suggested over here. Okay. And because the actual illumination is lower than what was the targeted illumination, so it means that there is some, loss of, because you are not getting the actual illumination as per the target, which means that there is energy wastage. So it can be calculated by the formula 1 minus ILR multiplied by the watts per watts, into operating hours. What means this is converted to kilowatt and operating hours. So 1 minus ILR at that place is 0.7. So 0.3 multiplied by 990 is the actual wattage, of the lamps, by 990 by 1000 kilowatt, and it works to 8 hours per day, 300 days. So actual loss of energy is 700 and 12 kW. So that is worked out over here. Okay. Then there is examples which are solved over here. I will not go through the example because these calculations we have already seen once. So heat gain calculation and internal heat gain calculation are to be done as per this, and this summary table of heat load calculation is to be worked out and presented. So and is to be compared with the design value. So this is how you assess the performance of both the AC system as well as lighting system. AC system is because is you work out the kW per ton of refrigeration and compare with the standard, and also work out the cooling load, to work out the AC performance, and lighting load. Of course, you have to make measurements and compare with the standard. Okay. So this is the theory part of this lecture. Now we will go to the question and answer session. Are you there, Suprita? You are there.
Yes, sir, I'm here.
Akshay, are you there? Hello, Mr. Akshay. I don't know what happened to Mr. Akshay. Okay, because he seems to be on, but he is not responding. Maybe having some problem. It seems. Okay. So let me go through the questions. So the first question is, define the average annual hourly EPI. Can you define, Saprita?
Kilowatt per hour.
EPI divided by the EPI divided by the working hours in a year. Okay.
862
Then define EPI.
Energy Performance Index.
Yeah. But yes. But what is the expression?
Expression, sir.
Total energy consumption divided by the uh, the area, built up area. Okay. Yeah. Then it mentions you uh, calculate the heat loss due to conduction from a wall. Okay. Now these heat loss calculations are uh, given in the you can see in the text. In the lecture it is mentioned over here. So I have done this calculation for you. So here, what is mentioned, the figures are given here is that you have got U factor of 0.284, which is mentioned over here. Then you have got the area as 9.3 m square, and temperature difference is 21, and outside is 9 degrees. So temperature difference works out to 21. 30 minus 21 is 9.4. But ASHRAE standard says that in case the temperature difference is less than 12, you assume the temperature, that C3 LTD, normal cooling load temperature difference is 12. So area is 9.3 multiplied by Q 0.284 multiplied by temperature difference of 12. That works out to, something, that figure works out to about 90. About 90 uh, is the total heat gain, okay, or heat loss due to conduction for the wall, or heat gain due to conduction in the walls. Okay. Next, go to the next question. Define ILER. So, can you define ILER? Okay. ILER is basically the installed load efficacy ratio. This installed load efficacy ratio is the ratio of actual lux expressed in watts per m square, lux per watt per m square. That is the actual elimination figure. And the design figure is target lux elimination level per watt per m square. So the ratio of two is installed load efficacy ratio. Do you get me? Mr. Prita?
Yes, sir, I got.
Okay. So then the question is 5. Define room index. From a room index, length is 10 meters, width is 20 meters. Calculate room index. So what is the formula for room index? Can you answer? Okay, so if you are not, yeah. Length into breadth, length into width, divided by height into length plus width. Okay, but height is not mentioned here. So you have to assume some height, because the figure is not mentioned here, and work out. I have assumed a height as 4. It calculated, so 10 plus 20 is 200, divided by, uh, divided by 10 plus 20 is 30, multiplied by height is 4. So that works out to, if you calculate this ratio, so room index works out to 3. So that is what you can get it. The next question is, what are the thermal comfort standards for temperature of as per NBC? So this, of course, you will have to go to NBC. You have to refer from the NPC. Okay. So this answer is not given in the chapter. Then there is another example, short example, which is the built-up area of building is 1500 m square and lighting load is 25 kilowatt. So calculate what is the lighting power density. Very simple. Can you reply?
Sir, I'm not able to fully see the question because I'm like
Okay.
on road right now.
I will I will answer for you. The total is 25 kilowatt is 25,000 watts divided by area 1500. So that division of 2500, 25,000 by 1500 it gives you the lighting power density. Okay. Now this is a very simple example. Total energy consumption of a building, is this is EPI calculation. What we defined. 32 lakhs is the consumption. 8,500 is the area. So what is EPI? Tell me someone. Okay, so 32 lakhs by 8,500 is the EPI. Now,
So 32 by 850.
yeah, 32 lakhs by 8500. Right. Okay. So that is the EPI. It works out to, if you work out, it will work out to something like 36. Okay, you can calculate that. Now, the last question is, sorry, ninth question is what wet bulb temperature, return air from HU 29, find out enthalpy. Now, this is a heat to, HVAC calculation. We will not go through that. And why is the water cooled refrigeration system more efficient than air cooled one? Can you answer that?
Yes, okay.
Okay, so basically these are the principles of water cooled systems are more efficient than the air cooled system. Any which will
Bring the
tell you.
treated air into the building, and the cold water is supplied very much close to the at the service point itself. And whereas in air cool, we are cooling and treating the air in a farther location and bringing it. So there's a loss of or picking up of heat due to which our temperature difference are very high. For example, if I have to use an air cooled chiller, I probably have to cool the temperature to 7 degrees, whereas when it comes to water cooled chiller, even if I bring it at 12 degrees, at the end point it will be servable.
Okay, okay. So and then question L1, L2, A3, these have to be solved on the basis of these solved examples are given over here. So you can use them and take these figures, for calculation and solve uh, these examples. Now, we cannot, for the want of time, we can't go through the calculations, but uh, easy to solve these examples by using the formulae, referring to the book. You can do it. Okay. So I think with that, we finished our, you know, discussion on this particular chapter of uh, assessment of performance of commercial buildings and uh, uh, and commercial establishment and buildings. Okay, so we close this. So this particular chapter, uh, and I think I can see uh, uh, some of the other staff members have also joined, for the conclusion of the course. Unfortunately, so I have to just inform my colleagues that, there are only two participants at the moment. I don't think anybody else, other than two have joined this particular session, a concluding session. So, and then Suprita is audible, but Akshay Wade, is not audible, somehow for quite some time, he had not answered any questions. So I really don't know whether we should go ahead with the concluding session in the fashion in which we want to be there. So, Mr. Shaligram, what do you want to say?
Just we can conclude.
Okay.
Okay, I think just within 5-10 minutes we can finish it.
Okay.
Basically, I would like to thank all the participants, even though they are not present here also. And particularly, I would like to really congratulate Suprita, because I think her attendance in whole this weekday course was much more than anybody. Maybe 95% plus must be the attendance, and very patiently she has attended all the class, and I'm sure she must have learned all these subjects very thoroughly. Uh, I think Chavan sir can give the lot of tips during this concluding session. So I would request Chavan sir uh, to just give these particular tips to the participants. Hope Akshay also must be listening.
Yeah. Yeah. Akshay Wade he said that yes, I am hearing, but he is not able to answer it. I can see there is
But
a very.
yeah, tell him to unmute then, or is he in the office or what?
Hello.
Ah, okay,
Yes, sir. I'm traveling, so
okay,
background noise. That's
ಆಯ್ತು.
it.
Okay.
Okay. So please
Yes.
unmute because there is some noise coming. Okay.
Yeah.
Yeah,
So,
yes, yes, yes.
Chavan sir, you can
Thank,
give them
thank you,
the
sir.
tips.
Thank you, sir. During my sessions, whatever I have taken, side by side, I continue to give tips then and there on each chapter, how to deal with it. But the general instruction which I give to the other batch participants also is that they will have to very coolly first read the questions. Let us not get confused or don't be under tension. Assume as if you have got a lot of time, and therefore coolly you read it. Once you read it peacefully, you will really understand what is the real problem. And then applying correct formula is the key so far as the numericals are concerned. For theory, I have also given them that you may face a small answer questions for 5 marks or whatever they design, and you have to write in brief so that you don't have to, because you know the answer, you don't write full pages only for 5 marks. You have to be precise and finish it in the earliest possible time to save on the time. My main thrust always I advise everybody is to score as much as possible in the first section, that is out of say uh, MCQs. MCQs is the key to pass the exam. Therefore, it is necessary to have the utmost command on MCQs. And the formula I suggested, and many also accepted that if you go through the MCQ section of earlier examinations, the answers and the questions both are available. Dr. Asmita has kindly already apprised you with the connected links for last 5 years question papers. So you go repeatedly through the solved question papers. If you are very much conversant with the type of MCQs they are appearing and the answers, then you will get a good scoring marks in the first section itself. Then what remains is the remaining two sections. The first section advantage is you will score sure marks. If you are correct, you will get 1 mark. If not, you will not get. But it saves time, lot of time. For 50 marks, you can hardly use 20 to 25 minutes, not even half an hour. Whereas you have got 3 hours to solve the entire question paper. So whatever surplus time you have after completion of section 1, you can utilize that time for delays in the problem solving or the numericals. Second, I will say the normal students and participant of this course, there is one age difference, great, because in student age you are used to sit at one place and write for 3 hours question papers. But in this exam, because of advanced age, because of habits are lost, and then you nowadays nobody writes with hand. Everybody either types or copy pasting is done. So you lost the art of writing fast correctly, right? And again, that will give you cramps in your fingers many times. Secondly, to sit at one place many times on a very hard seat in the college benches, and that too for 6 hours in a day, because you are facing 3 hours each, two papers in one day. So that again is a RDL you have to face. And therefore be prepared for that. You take light lunch or say snacks between the leaves period, the spare time you get between two papers. Don't carry much literature or the books or the notebooks and very hurriedly going through that before you appear for second paper. Try to avoid. All your preparation has to be completed before you prepare for exam. So on the examination day, just be feel free, because some people they come across some health problems also I have seen, and therefore they many times when they approach me they say sir वो तो आ रहा था सब, लेकिन जरा क्या तबीयत ठीक नहीं, मेरा सर दर्द हो रहा था, रात में ठीक से सोया नहीं. So avoid this. I mean, this is too elementary which I am telling you, and you are seasoned persons, you have faced many tension problems, but still it's a simple precaution, because you are appearing only for 2 days. So you have to survive these 2 days in a very healthy conditions. Regarding study, I will say all our faculties had a very nicely given you the perspective of how to go about the exam, what is the purpose of the exam, the very purpose denoted in this is to prepare you for a good energy auditor. If not for paper, but at least you should be a good energy manager. And with that view, the syllabus is very nicely designed. Books are excellent. Nothing will be asked in the exam beyond the limits given by the books. So everything, if you repeatedly read the books itself, then you are confident to go through and get 50% marks, right? So with all the best wishes, I wish you luck. As our chairman has said, you intimate your examination seat number so that when your result comes, we may be able to trace out how many of you are successful in the exam. Even if you are not fully passing all the papers you appeared, don't get discouraged. In the next attempt, you will go through it. So with this, I give you all the best and stop here. Over to you, Gandhi sir.
Since another faculty, Mr. Pramod Daspute, has joined, so Mr. Daspute, you want to tell something to the participants, because you were there, last few days.
Yes, sir. Am I audible?
Yes.
Particularly, Suprita has attended many of my lectures, and again, Akshay was there few times. This weekday batch was very short of participation, but still, Suprita has tried her best, and I wish all the participants very best for attempting the exam. And actually, I have given many clues like you can all the problems in paper 2, that is I have covered around 5 to 6 topics of paper 2 as a whole. So out of 9 I have covered around 6 topics. So ultimately I feel that if you just prepare the basic idea, basic logic, basic concept of q equal to mcp delta t and try to apply it properly, the paper 2 is quite easy. Already I have explained this many times everywhere, and accordingly you have to prepare. The paper 2 is much easy than even paper 3 also, but solving all 5 question papers given in the website of NEC and all will help you a lot to success in this exam. With all this, I wish you all best of luck. Thank you very much. Over to Gande sir.
So it's my uh, you know pleasure to see that all the participants will I wish that all of them will uh, appear for the examination, appear for the full examination, and pass the examination with flying colors. It is not necessary that we should always try to score 125 marks, 130 marks out of 150. Passing marks is 75. We must get in all three papers 75 plus, and the fourth paper 50 plus to clear the examination for energy managers auditor. So please try for that. Do not exert too much to, it's if you score more in one paper and then don't score 75 marks in other paper, then you cannot get the energy manager certificate. So try to see that your studies are balanced, your answering is also balanced, so that you make sure that you pass all the four papers, you know, three papers for the energy manager and fourth one for the auditor to get a certificate. And I'm sure this is both Akshay and Suprita. They will be appearing for the second time. So definitely they have experience of giving the examination once. It should not be very difficult for them to appear for the examination and pass it. This time we want to see that both of you clear, and other participants also. Our message goes to them that they should clear the exam. As we mentioned, please pass on your registration number, energy auditors and energy manager registration numbers for us to know your result, because otherwise we will not know what is your result. Even though we come to know that result is announced, but we will not be able to know your result particularly, in which we are interested. Uh, our faculty members, as all Shaligram sir and Chavan sir and Datpute sir have said, they have tried their best. In fact, as you have also observed, the total number of candidates was not very large, but we still conducted this course because of our dedication. And since you wanted the course to attend the course, we have, in spite of the small numbers, we have uh, taken up this course. And even though sometimes the attendees are number one, two, or three, for most of the lectures, my lectures, there were three, but sometimes it is even there was, and once it was only one or two. But we had not that did not deter us from delivering our lectures in the normal way. Okay, so as if the whole class is there, we have delivered. All our faculty members are. I thank all the faculty members for the efforts they have taken on you. Now it is our job to do justice to whatever efforts we have put in and what you will be putting in with good color. Our WhatsApp group will be there till end of this month, till your exam is over. So if you want to ask any questions to anyone, you can post that on the WhatsApp, or you can ask through the mail your queries if you may have on any one any paper. You can ask them. So our channels will be open till you appear for the examination. On 27, 20th. So all the best to you for the examination. So with this, I think we will close
Yeah.
our.
I would like to, yeah.
Yeah.
Yeah, I would like to add one thing.
Yes, please, please
To
conclude this,
both,
Shaligram sir. As a core director, you please
yeah.
announce the closure.
Yeah, yeah. Now, both I want to tell Akshay and Suprita madam. Now, since another week is there for the examination, if possible for you, my request to both of you, you can take a week, 1 week leave, and if you can study whole the things exclusively for whole week, you can dedicate for the study of all these four books. I think that also will help. at least I think you can request to your management to grant a leave for a week uh, for this examination, because they must be aware that you are appearing for this examination, and they also must be knowing the importance of this examination. So my request you to talk to your management and get a 1 week leave uh, till the end of your
Exam.
uh, examination. This will greatly help you, because whole week you will be studying, and you will so that whatever knowledge you will be getting in this particular week, or studying this week, uh, that will help you to write the particular paper. Okay, so this was the only one point I wanted to emphasize. Rest of the points have been already mentioned by uh, Professor Chavan sir, Professor Gande sir, Professor Daspute sir. They have explained it very nicely, and all three whatever they have mentioned you about these MOCs, um, those answers absolutely I also agree with their views,
Opinion.
because if you can solve those MQCs, definitely you will clear your those all the papers, uh, and that will also show you your preparedness for this examination. If you can quickly solve those MQCs, definitely that shows your uh, level of clear studying this particular subject. Okay, so with this, I thank you very much to everybody. I wish all the best to all the participants for their examination.